All right, so before we start graphing, hopefully you guys noticed with the transformations through the investigation that they're exactly the same. And this is what I've been preaching to you guys since we started graphing with transformations. Regardless of what the function is, A, B, H, and K are all going to have the exact same effect. So obviously our functions look different. A parabola doesn't look the same as a cubic and so forth. But A, B, H, and K have the exact same effect on those functions. Hopefully you have this written down. It is in modules for you if you need to look at it. But what is something new are these characteristics. So first one I want to talk about is period. And period is how long it takes the graph to recycle. Okay, so it is the length of the cycle or pattern. Okay, it is how long it takes for the coordinates to start repeating. How long it takes for the coordinates to start repeating. To start repeating. Okay, so if we think, and you'll see it when we graph here in a second, but if the period is how long it takes for the coordinates to start repeating, that means that it's going to be affected by the b value, okay? So sine and cosine have a period of 2 pi. So it takes 2 pi radians for the graph to start repeating the behavior. It's going to be affected by b. So we're going to divide it by b, not the reciprocal of b. Okay, b. So you can, if you want to, think of this as 2 pi times 1 over the absolute value of b, because yeah, it's exactly the same. Know that I will never write it like that. I will always write it like this, but you can think of it that way. Now for tangent, tangent has a period of pi. There we go. So you can think of this as pi times 1, fudge. Right. 1 over the absolute value of b, because of course it's the same thing, but I will always write it like this. And we say absolute value of b because sometimes there's a horizontal reflection. Okay, and that means that it's going to obviously flip over the, pardon me, y-axis. So we don't really care about the reflections when we're changing the period of our function. That's why it's the absolute value. Okay, amplitude. Amplitude will be written AMP. Lazy, sure. Efficient, I like that one better. And amplitude is the A value. A affects our vertical stretch or compression or maybe reflection, but we're only caring about the stretch or the compression. Okay, so that's why it's the absolute value. And amplitude is this. Well, there's a couple different ways. I'd like for you guys to write them all down to describe amplitude. Okay, first is half the distance between the maximum and the minimum values. Okay, so half the distance between the minimum and the maximum values, or, well, and it can be described as the distance from the midline. And we'll talk about all of that good stuff. From the midline to the max or minimum value. And notice it says that secant, cosecant, cotangent, and tangent do not have an amplitude. And that is because they do not have maximum or minimum values. So you can't find half the distance between values that don't exist. You can try. It won't happen. Okay, so period, amplitude, these are new to us. It's very exciting. Let's get to graphing. First, our parent function. So go to that first page for me, if you will. And we're going to graph sine. Okay, so I'm going to do my sine functions in blue. Cosine will be in, pardon me, in green. Okay, so we know that the sine period is 2 pi. Because I already told you that. And the amplitude for sine in the parent function form is 1. Because it goes up to 1 and it goes down to -1. There isn't any vertical or horizontal shifting because this is the parent function, okay? I talked about the midline. The midline is a line. I won't ask you for the equation like we do for the asymptote, but it's really important to understand where the midline is. For our parent function, the midline is always at the x-axis. Sound familiar? Midline is at y equals 0. Okay, and for our trig functions, the x-axis is always in radian measure. So for us with the unit circle, we start at 0, and then it goes up to pi over 2, and then it goes over to pi, 3 pi over 2, 2 pi, and so forth. And I always go one to the left. You can keep going if you would like. Okay, so then we've got 5 pi over 2, and then 3 pi, and 7 pi over 2, and 4 pi. Now, if I am sine, and I'm at 0, what is the sine of 0? It is 0. So let's go ahead and write out our coordinates. If x is 0, sine is 0. If x is pi over 2, sine is 1. If x is pi, sine again is 0. If x is 3 pi over 2, sine is negative 1. Oopsies. And if x is 2 pi, sine is 0. Hopefully you're noticing a pattern, and that's because there is one. Sine and cosine oscillate back and forth between their maximum and their minimum values. So it's going to curve as such. Okay, do not please make it look like a bunch of, pardon me, a bunch of, what's the word? Absolute value functions, because that is so not what that is. All right, so for the domain, our domain is all real numbers for our parent function sine function. And then the range, it goes between -1 to 1 inclusive because we bounce back and forth. We actually exist there. Or you can say that y is between -1 and 1. Neat. Let's transform it. Let's do it. Okay, so page 3 with me, please. Make sure that you always factor out the b value if it exists. So for our example number 1, we're going to have -2 sine, factor out the 2, x minus pi over 2 plus 1. What are the transformations? Well, there is a -2 in front of sine. So that means that we have a vertical reflection. That means that we have a vertical stretch. If you're wondering how that is possible, think of this as -1 times 2. Our b value is 2, so that means we're going to have a horizontal compression. H is pi over 2, so we're going to go pi over 2 units to the right. And k is 1, so we're going to go 1 unit up. All right. Remember our parent function points. X went from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. Okay, just going around the axes on our unit circle. For those of you that took the time to memorize the unit circle as suggested, this won't be hard. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And then sine of 2 pi is 0. Okay, and so as we've done in the past, sorry, with my stupid cough, b, the reciprocal of b affects x. So we have 1/2 x plus pi over 2, because that's our h value. A is going to affect the y value, so -2y, and then plus 1, because that's our k value. So then if we substitute in our x values first, I plug in 0, I get pi over 2. I plug in pi over 2. Okay, that's going to give me pi over 4. Getting common denominators, that means that, here, I'll write it out for us. Pi over 4 plus 2 pi over 4 is going to give us 3 pi over 4. If you plug in pi, you get pi over 2 plus pi over 2, which is 2 pi over 2, which is just pi. 3 pi over 2 gives us 3 pi over 4 plus 2 pi over 4. Common denominators, 5 pi over 4. And then if you plug in 2 pi, you get 2 pi over 2 plus pi over 2, which gives us 3 pi over 2. All right, for those, if you need to write them out, please do, you guys. Okay, just because I'm doing a lot of it in my head doesn't mean you have to. Remember, I've been doing this a while. Don't call me old. Okay, if we plug in 0 for y, we get 1. If we plug in 1, we get negative 1. If we plug in 0 again, we get 1. If we plug in negative 1, we get 3. And then if we plug in 0 again, we get 1. All right, so amplitude. Right now, it looks like it's oscillating between negative 1 and 3. So that is 4 units apart. Half of that is 2. Okay, or you can just look at your A value. Remember, it's the absolute value of A. So that means the amplitude is 2. Our wavelength, our period, because notice the sine function goes in waves. It's cyclical. It oscillates. All these fancy words. So it's going to be 2 pi divided by the absolute value of B, which is 2. So this is going to take pi radians, pardon me, to oscillate, to restart over. Okay, so when we're graphing, now it says graph with the appropriate scale. Use your period, amplitude, and pattern of your points to help with the scale. I know that it's going to take pi radians to start. To start over. So I always go out for tick marks. If you go back to the original, notice it takes 1, 2, 3, 1, 2, 3, 4 to start repeating again. That's how far out the period goes. So I'm going to use that as my general rule of thumb. I'm going to go out 4 tick marks, and I'm going to label this as pi, and then 2 pi. Well, pardon me, in between 0 and pi, if I take pi and cut it in half, I get pi over 2. If I take pi over 2 and cut it in half, I get pi over 4. So every tick mark is going to increase by pi over 4 radians. So pi over 4, 2 pi over 4, 3 pi over 4, pi, or 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And you'll notice that we see some of those in our transformed function chart, which is really nice. And then I always go to the left also so I can get a full picture of what my function's gonna do. We're very specific on what we want you guys to have labeled, whether it's 1, period, 2, etc. And then we need to go up 1, and we need to go down to, whoopsies, we need to go up to 3. Hello, pay attention. Down to negative 1. Now, think about our midline, right? The midline was smack dab at the x-axis. So if I needed to shift that, how did we shift the horizontal asymptote? We shifted it with k. So if you need to write down that the midline shifts with k, and since here we have a k of 1, that means that our midline is going to be at 1. Get into the habit of sketching the midline because it helps us when we're graphing our points, which we're about to do. Here we go. Pi over 2, 1. 3 pi over 4, negative 1. Pi, 1. 5 pi over 4, 3. 3 pi over 2, 1. And because we know the pattern that it's bouncing back and forth, we can easily create more points to help us graph our sine function. And then we're going to connect them in a curve, not an absolute value function. Don't you dare. Okay, there we go. The domain is all real numbers, or negative infinity to positive infinity. Unless we restricted it, there's really no way for it to be anything else. And then the range is going to be from negative 1 to 3, or we can say negative 1 less than or equal to y less than or equal to 3. And again, it's inclusive. We have to have that equal to those brackets because those are our maximum minimum values. Awesome. All right, so that's sine. I want to go back to the beginning where we have our parent functions listed out, and let's look at cosine. Now we're going to approach it in a very similar manner. I already told you that the period was 2 pi at the beginning. I'll tell you right now the amplitude is 1. We are dealing with parent functions that's not going to shift at all. So it's going to go up 1 down to -1, and our x-axis is still in radian measure. So if you think about, we start at 0 and then up to the y-axis is pi over 2. Down to the negative x-axis is pi, and so forth. 3 pi over 2, 2 pi, and you can keep going if you would like. Our midline is still going to be at the x-axis because there hasn't been any transformations. And let's write out our points so that we have them. If I'm at 0 and then pi over 2 and pi, and then 3 pi over 2 and 2 pi. Okay, unit circle masters, what is the cosine of 0? Hopefully all of you said 1. The cosine of pi over 2, 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. Graph it. Let's do it. 0, 1. And keep going so that we can see the full wave. Okay. When you connect it again, we are not creating absolute values. They have to be curved. Beautiful. So notice sine starts at the origin for the parent function. Cosine starts 1 up. Why? Because at 0, cosine is 1 and sine is 0. Nice. All right, let's transform this. Go to page 4 with me, please. Okay, so example number 2, again, always factor out a b value, if possible. So y is going to be equal to, our a value is 3. So that's our amplitude. Cosine of -1/3 times x minus 2. Okay, so since our amplitude is 3, since a is 3, we're going to have a vertical stretch. Our b value is a -1/3. So not only do we have a horizontal reflection, okay, so we just talked about starting at 0, 1. If there's a horizontal reflection, is that going to change? Good. No, it shouldn't. If there was a vertical, yes. And there's a horizontal stretch because the b value is 1/3. There isn't an h, okay, and k is -2, so we go 2 units down. Why does my computer hate me sometimes? Hello. Okay, there we go. So 2 units down. Nice. All right, let's go ahead and write out the parent function points. I know we wrote them on the chart at the beginning, but if you don't have them readily accessible like I do not, we need to have our points for reference. So our x values go from 0 to 2 pi. And the cosine of 0 is 1. The cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Whew. Okay. The b value affects our x. So we're going to take the reciprocal. We're going to say -3x. And there isn't an h. And then a times y plus or minus k. All right. If we plug in 0 for x, we get 0. If we plug in pi over 2 for x, we get -3 pi over 2. If we plug in pi, we get -3 pi. If we plug in 3 pi over 2, we get -9 pi over 2. And if we plug in 2 pi, we get -6 pi. All right, take your y values. Substitute in 1, you get 1. Substitute in 0, you get -2. Substitute in -1, you get -5. Substitute in 0, you get -2 again, and then substitute in 1 and you get 1. So there's our points. Awesome. Characteristics. Well, the amplitude we know is the absolute value of a, which is 3. We can see that our maximum and our minimums, right, are 6 digits, units, tick marks apart. Half of that is 3. Okay, the period of our parent cosine function is 2 pi. We're going to divide that by the absolute value of a negative 1/3. So our period here is going to be 6 pi. Okay, in case you're like, what did she just do? 2 pi divided by the absolute value. So I'll just take the negative away. Hopefully you guys are okay with that. 1/3, which means it is 2 pi times 3, and voila. Lots of arrows. Hope you're with me. Okay, the midline again is affected by k. So we can say that it is going to be at y equals -2. All right. Graphing with the appropriate scale. Remember what I said, 4 tick marks out. And this one is 6 pi. I always go right and left. This one's important to go left because you can see that your x values are negative. So we're going to need that. I'm going to go out and do 6 pi. What's half of 6 pi is 3 pi. What's half of 3 pi? 3 pi over 2. So every tick mark is increasing by 3 pi over 2 radians. So we have 3 pi over 2, 6 pi over 2, 9 pi over 2, 12 pi over 2, 15 pi over 2, 18 pi over 2, which is 9 pi, and so forth. Good. And then, yes, we do need to go in the negative direction because that's where our points are existing. Our maximum is 1. It looks like minimum is -5. So I'm going to go up to 1. I'm going to go down 1, 2, 3, 4, -5. I also need -2, so I'm going to label that to make my life a little bit easier. Okay, the midline is at -2, we found out. And let's graph. So 0, 1. And then -3 pi over 2, -2. And -3 pi, -5. Come on. And -9 pi over 2, -2. And -6 pi, 1. Go ahead and recreate that on the positive side because the pattern doesn't change. It's bouncing back and forth from the midline. And then you can draw in your curve. Ours might look a little bit different in width, but keep in mind, you guys, that as long as your points are the same, that's what matters. This isn't graph paper, so if they are looking a little bit wonky, that's fine. We're not doing like measured out tick marks. It's okay. Okay, so the domain, again, is all real numbers because it's going back and forth. We haven't restricted it. And then our range goes from -5 to 1 inclusive, or -5 less than or equal to y, which is less than or equal to 1, because those are our maximum and minimum values. Excellent. All right, we got one more. One more so you can have it in your bag of tricks. Example number 3, this is our last one. Make sure you factor at the b value if there is one. And of course, you're welcome, there is one. So y equals 2 times the sine of pi over 6 times theta. Remember, theta is the angle measure, okay? When we're going around the unit circle, the angles are always our x values. Well, technically it's cosine, so sorry. But theta represents the input, okay? So transformations, if a is 2, that means we have a vertical stretch. Pi over 6, so it's 6 over pi. Now, I don't know about you, but I don't know what that is off the top of my head. So if I grab my calculator, I take 6 over pi. Yeah. So here, let's do pi over 6 first so that we know. Okay, so pi, oh fudge, over 6 is approximately 0.5, but we need the reciprocal. So 6 over pi is approximately 1.9. We can say that that is a horizontal, good, horizontal stretch. And then k is 1, so we go 1 unit up. Nice. All right, parent function points, you already know them. It goes from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. Sine of 2 pi is 0. These are seriously probably the easiest parent function points for you. Ay, ay, ay. You're welcome. Okay, so for b, it's going to be 6 pi times x. You can use x. If theta bothers you, just use x. It just means input, okay? It's the exact same thing. There isn't an h value, so we'll leave it. And then we have a times y plus 1. Excellent. Okay, if I plug in 0, I get 0 for x. If I plug in pi over 2, don't be frightened. This is okay. If you plug in pi over 2, you end up with 3. It is still radian measure. The pi is gone, I'm aware. So we're just dealing with integers. That's okay. All right, if we plug in pi, we get 6. If we plug in 3 pi over 2, we get 9. If you plug in 2 pi for x, you get 12. Okay, if we plug in 0 for y, you get 1. If you plug in 1, you get 3. Plug in 0, you get 1. Plug in -1, you get -1. Plug in 0, you get 1. All right, the amplitude is the absolute value of the a, which is 2. Again, max, min, 4 units apart, 4 tick marks apart, half of that is 2. The period is 2 pi divided by the absolute value of b, which is going to work out to be 12. Again, if you're like, what the heck? It looks like this. We're dividing by pi over 6. So 2 pi times 6 over pi, those cancel, and we get 12. The midline is adjusted by k, so our midline is at y equals 1. Nice job, guys. All right, graphing it. Hopefully it's getting a little bit easier. Don't worry, we've got lots of practice for you. 4 tick marks out, get me to 12, okay? Remember, from the original, we went 1, 2, 3, 4 tick marks out, and that gave us the period. That's because the parent function, that's how long it takes. So it's just easiest to do it that way. We get comfortable with that. We get ourselves into a rhythm. Half of 12 is 6. Half of 6 is 3. So every tick mark increases by 3 units. 3, 6, 9, 12, 15, 18, 21, 24. And we'll go in the negative direction. Looking at our points, we need to go all the way up to, our points, we need to go all the way up to 3 and down to -1. Our midline is at a +1. I did this in blue. Oh, sorry, guys. Bummer. All right, so the midline is at 1. I know that probably only annoys me, but if you were irritated by it, I'm sorry. Okay, so we have a coordinate at 0, 1, 3, 3, 6, 1, 9, -1, 12, 1, and I'm going to continue the pattern that I see. This is why the midline helps. If you're not on the x-axis, oftentimes it's harder for us. Well, it helps if your midline's straight. There we go. And then go ahead and connect it. With arrows. Oh, Lordy, please put the arrows. Okay, our domain is all real numbers. Hopefully you're seeing a pattern with that, because there is one. And then the range for us goes from -1 to 3 inclusive, or -1 less than or equal to y less than or equal to 3. Nice. Okay, so I lied. I have 2 more examples, but these will go quick and they're important. So for example number 4a, it says write a sine equation that has the following characteristics. Okay, so the amplitude is 2. That means that's a. The period is the thing that sort of trips us up sometimes. We know that the period for sine is found by 2 pi over the absolute value of b. Well, we're told that the period is pi over 12. What is b? Some of you might be able to see it. Some of you might not. Okay, so cross multiply. We get 24 pi is equal to b times pi. Divide both sides by pi you get b is 24. Okay, write it out if you have to, please. So we'll get y, here I'll do it in blue. I know, longest notes ever. Okay, y is equal to 2 times the sine. It says reflection of the x-axis, so that's a vertical reflection. Okay, so we'll put the negative in front of the 2. Our b is 24. X or theta, it doesn't matter. Horizontal shift right, pi over 4, so that means minus pi over 4. And there's your final answer. Sweet. Okay, so for B, you guys need to write a sine and cosine equation. Okay, find the midline, please. So important. Well, my max is 2, my min is -4. They're 6 units apart, so that means my midline is 3 units away. So if I go 1, 2, 3, my midline is at -1. This is important because sine starts at the midline, usually, right? The origin. So if we do the sine function first, I'm going to pick here to be my starting point. It doesn't really matter what you pick, okay? So if I start there, well, shoot, I need to know what this guy is. So what's half of pi over 2, pi over 4? Okay, so for my sine function, I'm going to go right pi over 4 units. It also looks like I went down 1 unit because the midline's not at the x-axis, okay? We know that we go up from this point, from that point, we go up 1, 2, 3 units. So the amplitude is 3. And then it goes around here. So let's see, I go pi over 4, right? Pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4. So the period, let me make sure I did that right. So 1, 2, 3, 4, nope, 4 pi over 4, sorry. If we start here, 1, 2, 3, 4, it takes 4 pi over 4 radians to start over. Okay, so if our period is 2 pi and it's divided by b, what must b be? B has to be 2. Cross multiply if you need to. Okay, so then we can write the equation. Y is equal to, okay, our amplitude is 3. I'm going to cross it off because I'm going to put it in here. Sine. The b value is 2. We go right pi over 4 units. And we go down 1 unit. So there's our sine function. Now you might choose to start here. And that's fine. But on your equation, you're going to have a vertical reflection because I go down. Okay? It doesn't matter where you're starting. You could have something totally different than me, and we would still generate the same curve. That's going to be bound to happen. Okay? It's wherever you see it. And the more you practice with these, the easier it becomes. The more you graph, the more you can write the equation and so forth. Okay, so let's take a look at cosine. Okay, so cosine normally starts above or below the x-axis. We're used to seeing it above, but for today, so we can get that practice, I'm going to start here. Okay, if I don't start up and I start down, that means that there is a vertical reflection. Okay, and normally I am 1 unit above the midline. Today I am 3, so my amplitude is 3. Cosine and sine have the same period, but let's just make sure if I go up and then I go down, haha, that's where I'm going to start again. So my period, which is normally 2 pi, is now pi, which again, yes, the b value is going to be 2. I don't shift left or right, but I definitely did shift down 1. How do I know that? Because of the midline. So we're going to say that y is equal to, there's a vertical reflection, and our amplitude is 3, cosine of 2 theta minus 1. And if you guys need to, please, 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 if you need to when you're doing these, write out the equation. We know y equals a sine of b times the quantity x minus h plus k, and then y is equal to a cosine b times the quantity x minus h plus k. Nothing says you can't write that out first and then match the pieces. Okay, sorry, this was so long. I think it's really, really valuable though, and get to practicing.